So what is 1D motion? Can you help me understand? One-dimensional motion.
Straight line.
Sorry?
Will that be motion in straight line, or was that 2D?
Yes, motion in a straight line is 1D motion. Okay. Where you can go only in one direction, that is back and forth, back and forth, back and forth.
Yeah.
For example, you are riding your bicycle on a straight road. Okay, that is one-dimensional motion. Now, what is two-dimensional motion?
Projectile.
Yes, that is a 2D motion. Very good. So 2D motion, you are allowed to go only two directions. You can go forward, backward, and left and right. Okay. Like you can go forward, backward, or you can go left and right, or you can roam anywhere but in one plane. Okay. You can roam anywhere on one plane. For example, you are in a park, let's suppose, and you are walking. So in a park, you are allowed to walk in any direction you want. Okay. So you can go left, right, you can go any direction. Okay. So that is an example of two-dimensional.
Yeah.
Okay. 2D. What is 3D?
Then that 3D will also include the Z direction, then I would say, right? On the cardinal plane.
Very good. It includes the Z direction. Okay. It includes the Z direction. Just one second. Okay. So for example, you are driving you are driving, you are flying a helicopter or an aeroplane or maybe a submarine. Okay. So that is an example of
Three-dimensional.
three-dimensional motion. What is four-dimensional motion?
Haven't got a clue.
Okay. So what do? You just add. You must have heard in movies and series and lots of scientists discussing about the fourth dimension. Fourth
The
dimension. Sorry?
quantum? I don't know.
No. Fourth
No.
dimension.
Yeah.
Time.
Oh, okay.
Fourth dimension is time, nothing else. So you just add time. It becomes four-dimensional motion, nothing else. Okay. Just a second. Okay. So yes. So if you have to depict one-dimensional motion using one variable, so which variable would it be? X variable.
X
Okay.
variable.
You have to depict 2D motion.
X
There
and
would
Y.
be X and Y. 3D for 3D would be
X, Y, and Z.
X, Y, Z. For 4D, there would be
X, Y, Z, and time.
X, Y, Z, and time. Okay. So just give me a real life example of 1D.
One-dimensional, just walking in a straight line.
Very good. Walking in a straight line. 2D is walking in a park where you can take left, right. You can go forward, backward, or you can remain on one plane. You should not be changing planes of motion. Okay.
Yeah.
It's not like you are walking in this plane and suddenly you got suddenly you are going maybe on a hill, or maybe you are going uphill or downhill. That would be changing plane. Okay.
Yeah.
So you have to remain in one plane. You can only be in this plane. Okay, you can only be walking in this plane. You cannot go uphill or downhill. Okay. That is 2D. 3D is just add the Z direction. Now you can go uphill, downhill. Okay. You can walk uphill, downhill, or maybe you can fly a helicopter or an airplane or submarine. You know what a submarine is?
Yeah.
What is submarine?
An underwater boat would be a good description.
Yes, very good. The underwater boat, basically, which can go under the water, okay, and it is sort of like invisible, okay. It's like basically stealth mode, you can say, for a boat, okay, which is very useful in wars and fights, okay. Wars, it has been very useful, okay. And the fourth dimension is time. You just add the time parameter. Okay, you can just assume you are wearing a wristwatch to make sense of time, to keep a track of time. So that becomes four-dimensional motion. Okay, very good. You know the basics. You have understood the basics pretty well. Okay, now that you have understood the basics, okay, tell me what are scalars and vectors.
Scalar quantities are those with just a magnitude, while vectors also have a direction.
Very good. You already know it. See, if you know things, we can go
Yeah,
very far.
that's true.
And yes. So vectors is nothing but physical quantities which have magnitude as well as direction. For
Sorry.
example, if someone asks you, what is, for example, you are having fever, and someone asks you what is your body temperature, what do you say?
23, like, I don't know, 100-degree Fahrenheit.
Yes. For example, 103 degree Fahrenheit or like that. You say, do you mention direction there also?
No,
No. So temperature becomes
scalar.
a scalar. Okay. In the same way, when you say, when you go to a vendor and you say you want to have, he asks you how much apples do you have, or do you want? So you say, I want 5 kg apples. Okay. So you don't, do you say you want 5 kg apples in that direction or that direction?
No,
No.
it's also scalar. Yeah.
Mass is also scalar. Okay, you don't have to specify direction. But if someone asks you direction, okay, where is the nearby hospital? So you say go 5 kilometers in that direction. So in that situation, what when you are guiding someone, okay, so that basically becomes a vector. When you are telling someone a physical quantity which has magnitude as well as direction, you are saying go 5 kilometers towards north, for example. Okay, that becomes a vector. Okay, you can assume you are talking about the displacement vector here. Understood?
Yeah. Yeah.
Okay, let's quickly, we will watch videos. I mean, I like to explain lots of things with the help of videos and simulations. So we will go back to simulations and everything. But before that, just a little brief of very basics. Okay, that is distance and displacement. What is it? What is the difference?
Distance and displacement. Distance has just the magnitude, while displacement also has direction. It's a vector.
Very good. This is scalar and this is a vector.
And
And
distance is like the total path length travel, while displacement is the shortest distance.
very good. It's like the shortest distance from point A to point B. Distance
Yeah.
is like how have you traveled in the entire path. So basically the distance, the sum of all the routes and all trajectories you have taken during your whole journey. Okay,
Uh-huh.
that is called the distance. Very good. You already know it. Now tell me the difference between speed and displacement. Speed and velocity.
Let's see, speed and velocity. Uh, Speed is the displacement, distance upon time, while velocity is displacement upon time.
Repeat that again.
Speed is the total distance traveled in upon time, like distance traveled
Yes,
per
correct.
time, while velocity is the displacement traveled per unit time, essentially.
Very good. You already know this. Very good. So this is nothing but distance over time, and this is displacement over time. Okay. So speed becomes
Scalar
a scalar quantity, and velocity becomes a
displacement, vector.
vector quantity. Okay. So velocity and speed are pretty much similar. You just add a sense of direction to speed, you get velocity. Very good. Okay, I think we can go to the simulation. You already know the basics.
Mm-hmm.
Okay. Uh, do you understand projectile motion?
Projectile motion, I have a bit of issues with it, like when I do it.
Okay, no problem. I'll explain everything easily with the help of simulations. Okay. I'm sending